Hey guys, this is Jom and welcome to Shiv Raja, your gateway to future. So guys, in today's session, we are going to talk about slab design. So basically, first of all, we will design the slab in RCDC and then we will go for the manual design of the slab and then we will compare the results also. And I will also tell you which slab design I prefer personally in my professional work. Okay, so I am just going to take you to my screen and over here you can see I have my STAAD Pro model ready with me. Now, what I have to do, I have to simply, first of all, analyze this and then we will go for checking whether we have any kind of errors or warnings. Well, as far as I remember, we have zero errors and zero warning. Now, we have to simply click on Advanced Concrete Design and it will take us directly from STAAD Pro to our RCDC, which is our design and detailing software. So analysis and design can be done in STAAD Pro, but for like detailing, we have to look towards the RCDC and there we will choose the slab and then we will choose the level at which we want to design the slab and for us it is 3.2 meters, so we will click on create project where it will take some time to read all the data of the file which we have imported from the analysis file of our STAAD Pro. So you can see everything is being brought up here and now you can see we will have a file for our design input. Now, since we have imported this in a detailing software, so you can easily see that we have like every panels separated and all the panels have their slabs with like their specification like two adjacent edges discontinuous. Okay, so you can see if we are talking about this slab which is S1, so this portion and this portion is discontinuous, so it is saying two adjacent edges like discontinuous. Then if you will click on the S4, then it is a interior panel, that means it is surrounded by like slab with all the sides. If we will talk about this one, then again it's a end span. Okay, so you can see this is a cantilevered portion, so it is end span. And then we will talk about S8, which is one long edge discontinuous. So basically this one has four edges, two long edges and two short edges. So two short edges are continuous and one long edge is continuous, but one long edge is discontinuous. So it is categorizing your slabs according to the IS codes. Okay, so if you have studied the code, you must have known all these things. Now what I'm going to do over there, first of all, I will simply import like write down my imposed load and the live load. So you cannot just make any load zero over here. So what I'm going to do, I will simply enter the loads uh, over here. So I want to like provide 2 kilonewton per square meter. So I will simply provide one as the imposed load and one as the live load. If you want to increase the load, you can also go for 1.5. So I will also show you this one. Then what is should be the thickness of the slab? So the thickness of the slab in my case should be 4.5 inches, which is 113 mm. And then top of the slab, like if you want to like provide some kind of extra things over the slab, like suppose you are placing any kind of tiles and all the things, then you can simply design it for the top of the slab also. But basically we will start with our basic design. Okay, or if you want, then I can just write 50 mm over here, so that will include everything. Now I will simply copy this and paste this all over here. Okay, so let's paste it with Control V. So you can see it is pasting everything over here and all the details are provided over here. Now in cutout section, okay, so is there any cutout section in the inside the portion? So we don't have any kind of section, so we will simply skip that thing. Okay, now what we have to do, we have to like make some settings. So what should be the design parameters? So do you want to go with cutted bars or do you want to go with bent up bars? So any bars you choose, you can simply provide it over here. Okay, and Then I will go for the bent up bars because that's what is required in this particular portion of project. So over there they use bent up bars. Otherwise, you can also go for the cutted bar. Preferred reinforcement is 10 over here. Now detailing option is the rebar. Do you want to go for the rebar detailing or spacing detailing? So you can just go with any of them. Like what should be the spacing? If you want to fix that, then you can go for this one. If you want to fix the rebars, then you can switch over here. Now for the one-way slab, simply supported 20, continuous 26, and cantilever 7. So this is the preferred span divided by depth. Okay. Now for the two-way, we have the categories, and these categories are according to the IS 456 clause 24.1. So you can also cross check it into the code, and whenever the code is updated and suppose your software is not updated, then you can also change the values from here. Now we have the different rebar diameters that are available over here. So you can simply go with that. What is the grade of the concrete that you want to use? So if you want to use M20 grade of concrete, you can use that. If you want to reduce the grade of the concrete, so you can also define it. Okay, if suppose you want to go for M15, then you can simply check it from here. But this is a lower grade of concrete, so it is not being taken over here. So we can simply cancel this one, and we will go for the M20 grade of concrete. That should be the minimum grade of concrete in our day-to-day life. Now the cover of the main reinforcement should be 20 mm, and the minimum thickness should be 100 mm. Okay, so that should be the minimum thickness of the slab. So I'm just going with that. Now since I want to restrict my slab thickness, so I will simply just go with 113. Okay, that is not 100 mm, or you can just keep it 100 mm because I have already provided the thickness over there. Okay, so if you want to use the material property from the analysis, then you can also go with that. And then we have this minimum spacing and then maximum spacing, which is provided over here. Now the round-off value I will keep as 25 mm because in the end I want to generate my results in feet and inches. So 5 mm accuracy will not be enough for me. Now over here you can just go with the preset values, so like a T10 at the rate 120 center to center spacing. So this kind of a spacing you can simply prefer. Okay, which is quite good over here. I'm with quite good with that. Now if you want to perform the check, then you can simply go for the permissible crack width of 0.2 mm, and then we have this up. If here, like, this means that if there is some kind of crack happening of let's say 0.3 mm or 0.4 mm, then that will be discarded. Okay, now you can see I am going with IS 456 with effective cover. Okay, so that is taken by default, so you can simply just go with that. IS 456 is effective cover is 20, IRS 20. Okay, so I'm just going with IS 456 over here. Then initial thermal cracking, if you want to perform the check for all these things, then you can also go with that. Okay, so what should be the peak hydration temperature? If you want to just change that, then seasonal temperature variation and permissible crack width, everything if you want to change, then you can also change it from here. These are the basic things. Even if you are not going for that, then you can just go with that, go with the default settings. Set all panels as non-continuous. No, I don't want to set any panel as non-continuous. I just want to design it as it is so that I can get the best result. Okay, now in the setting over here, I will just go with uh, English system over here. Okay, now I will go for design. Okay, so factor affecting the continuity has been changed for some slabs. Do you want to reevaluate the continuity and proceed? So, okay, so I have changed the continuity. So anything, so you can just keep it like that. That is not an issue. Okay, now it will take some time to auto design your slab. And you can see we have our design results and all the slabs are passing with one M20 grade and Fe 500 of the steel. So T10 you can provide at 225 at center to center. Okay, in bottom LX, that means the shorter span, and longer span you can also go with that. Then the top bars is LX continuous over here. So you can just see the results from here. I will simply drag it a little bit so that you can have a better idea of this one. Then 50 mm raised. Okay, that is the remark. So you can just keep it like that. Otherwise, if you don't want to get this value, then you can simply just go to the design settings parameter. Okay, so I'm not unlocking the design, and from here, okay, so where it was. Okay, yeah. So initially in the design input thing, you have written 50, so you can simply make it 0. So over there, the remark will be nothing over here. Okay, basically either 0 or nothing. And then the distribution is still, that should be T10 at the rate 250 center to center. So this is the whole slab thing that we have got from here. And now I'm just going to generate the results for you. Okay, so if you want to categorize some slab, then you can also do that. However, the categorization is not very good over here. So you can just go ahead and generate the text schedule. Okay. Do you want to group the similar slab? If you want to group it, then you can also group it. So for now, I will simply group it so that I can have a better idea of what kind of thing I am getting. So basically, you can see the slab thickness is 4.45. Okay, so it is around 4.5. That is not an issue. And these slabs are two-way slabs. Okay, and then we have this one-way slab over here. And then again, these are S8, S15, and S16. Okay, these are one-way slabs. Okay, so S8, S15, and S16, S8, S15, and S16. Again, these are two-way slabs. Okay, so we can also check it from here. And then S7, S3, S17, and S8. These are like 7, 13, 17, 18. 7, 13, 17, and 18. So these are basically one-way slab. Okay. Now you can easily get the categorization in our design results. Okay. Now, if you want to go for a more detailed one, like general arrangement plan, then you can also generate it from here. That's not an issue. So you can see it is giving you all the things like 4.45 inches thick and then 1.97 raised. Okay, so that is the least raised thing over here. Then for the beams, you can get the depth and the of the beams, like thickness and depth of the beam from here. So this is a 10 by 10 beam and 10 by 15 beam. Okay, so you need to go for a little more accuracy over here if you want to go with that. Like in my previous model, I have already changed it, but somehow it is not taking that much of the accuracy. So we will skip that. However, we can just save these files in the AutoCAD, and from there we can simply go ahead and change it. Now I will just unlock these design values, and over here I'm going to make it 0 because that is not needed. So I will simply copy this value with Control C and then Control V. I'm just doing it because it is messing a lot with my design results. I've already shown you what these things do, but I'm messing since it is making my design results a little clumsy. So I am avoiding that. Now let's do a little bit of the calculation. Okay, let's open the calculator and we will do it 4.5 into 25.4. Let's see. It is coming as 114.3. 114.3. So this is the thickness that I'm going to provide because it is taking up a very high accuracy of 25.4. So I'm just going to make it like that. Now in the design input data, we don't have anything else. So let's design it. I'm just making doing the things so that I can get more better results actually. So I will go for the results, text schedule, group similar slabs. Okay, so now it is giving me 4.5 inches, which is way better than the previous one. I don't have any kind of remarks over here. Now distribution bars and everything that I can take the rounded value. Okay, which is quite okay. Even if it is giving me accuracy to change the accuracy, then I will also change it. So let's design parameters. Let's see 25.4. if it can be taken. Now we will go for the order design. And now let's check the schedule. So now it is giving me more accurate results and the accuracy has been increased. However, this is a common idea that how we have to, like, if it is coming 8.9, we can just go with 9. Or if you are just going with this much accuracy, then your reports will be generated in a fine way. So now you can see where we have to provide 9 inches, where we have to provide 10 inches. That is quite clear. We don't need to like think a lot over here. Same thing can be done for reports of general arrangement plan. Okay, so let's generate the report for that. So you can see here, all my slabs are 4.5 inches thick. Okay. Now, if you want to cross check whether it is passing at 100 mm or not, so you can also go with that. Okay. So like suppose I don't want to go with the thickness of this much. Okay. So I will go with the thickness of 100 mm. So let's say 4 inches. I will clear it. 4 into 25.4. Okay. So 101.6. Let's try this one also, like whether it is passing for 100 mm or not. Okay. So why 101.6? Because here we want to get our results directly from here. So I am just doing the modifications and we will see whether our slabs are passing or not. This is if you are going for the mm, just keep it 100. If you are going for the inches schedule, then you can just go like that. Okay. So 4 inches slab is there. And even in the 4 inches slab, everything is passing. Okay. So bottom reinforcement is passing over here. Just this one is not giving us the quite good results. S7, S13, S7 and 18. Okay. So this is not giving us a desired results over here. Let's see what is it is giving over here. So over here, everything we are getting from here, but in the schedules we are not, in the reports we are not getting the desired results. So we can just check out our this one. Okay, for the results, like you can just sorry, we have already generated the results from here. So yeah, here we can see these 4 slabs are not giving us detailed results of how much of the reinforcement should be there in the bottom direction. Okay, so I will show you how to read the reports. Basically, this is all the slabs. Okay, then we have the thickness of the slab, what kind of slab it is, either it is one way or two way. Then what should be the bottom reinforcement over here, and then in the top reinforcement, short span and long span continuous, and then we have this distribution bar. Okay, everything is quite clear. Now if you want to like group it, so you can simply group it. Okay, and for this much like S7, 13, 17 and 18, you can refer to the design results over here. 7, so you can see we have the same thing, 7, 13, 18 and 17. Okay, so one reason can be like this span is very small, so the reports could not be like quite good enough, like what should be the slab reinforcement distance over here. Okay, so that may be a case. But now let's jump for the detailed report of in-plan detailing. Okay, so you can simply generate the in-plan detailing from here. Let's see how explained, or you can how detailed this report can be. Okay, so you can see everything is coming great over here. Like what should be the exact distance? Okay, that is coming like this. Okay, but it may be a little clumsy for you. Okay, when you are just looking at things like this. Okay, however, if you will just download it and delete the files, okay, like a few data, so then you can just get a quite good value. Okay, that's not an issue. Now I will go for the slab section. So even if you want to like go for the slab, like any particular slab, suppose we are going for S6. Okay, S6. So I will just enter 1, then slab mark, let's say A. I will choose S6. Then it will automatically take up everything. What should be the LX and LY? What should be the edges? Okay, we will go for the standard cutout drawing. And then we have to mark these things. Like left mark A, then left B mark. Let's keep it B. Or just go with these initials. Right, this should be B. And let's draw it. Okay, so we are getting our standard a detailed section of the slab. So you can see everything is quite clear over here. This is the standard one. If you want to like go for a different, a more detailed one, okay, so you can simply just uncheck this one and then you can go for one. Again, we will go for the S6. Then we will go for the markings over here. V, 1 and 2. Section mark. Slab S6. So here it is. Okay, let me generate a new one. Okay, I guess it is not like appending this one. So I will generate a new one. Slab section. It is not giving as detailed as expected. Like I'm using a new software over here, but still it should give me much more detailed than this one. Let's see what we can do over here. Let's 1B1 2. Draw new. Okay, so it is not showing the beams over here. Okay, but that is not an issue. We can just get the slab section like this. That is quite good with us. Okay, and everything, if you need it, it can be changed. Okay, so that is all about slab detailing in RCDC. Now what we have to do, we have to just design the slab manually with like Excel sheets. So before we jump to that section, I would like to request you one thing. Like if you have liked the knowledge so far, so please hit the like button to this video. If you find someone who can be in need of this video, then you can share this with them. And if you haven't subscribed to Civil Raja yet, then please subscribe to our channel because we will try to provide as much informative videos as possible. And if you want us to make some videos on any particular topic, then you can also comment that in the comment section. If you want my professional training, then you can simply connect me through WhatsApp or call on this number, which is 8433248864. And you will also find this number in the description. Now we will I will do one more thing. Like I will simply save all these drawings. Okay, so basically I'm just going to save this file name. So this is slab layout. Slab layout at 3.2 meter. Then this is section of slab. Let's see if it has been saved or not. Yeah, it has been saved. Now for the slab section, I will just go with slab section at 3.2 meter. Then bent up reinforcement. We will save this one also. Then we will go for the slab schedule. Okay, and then I will take up a screenshot of this design results. So that it can be helpful for me in the upcoming videos, or sorry, in making the project. Okay, now I will take you to my Excel sheet over here. We will design the slab. So we need to take the write down the length and breadth of the slab. So we will go for the one-way slab over here. Okay. So let's try the one-way slab first, and we will see whether it is working fine or not. So here we will go for design input. You can see, first of all, I will design S3. Okay. So it is one edge, one short edge discontinuous. Okay. 3.71 and 3.86. So first of all, we will have to enter the value of M20. Then FE 500, slab thicknesses should be 100. Width is 100 mm, 1000 mm. Okay. Then we will keep it like that. Clear cover is good. Short span. What is our short span? So it is 3.71. 3.71. Then our longest span is 3.86. 3.86. And this is a one-way slab. Sorry, two-way slab. Okay, so we will go for a one-way slab. Okay, what is one-way slab over here? 0.74, 2.13. 0.74, 2.13. So now this is one-way slab. Okay, and the thickness is 100 mm. Okay, one end it is continuous. So you can see it is providing, if you the spacing that we have provided is 150, then it is quite good over here. Now let's, since our slab is giving us a quantity of 9 inches. So let's see whether it will be safe at 9 inches or not. 25. 9 into 25. 225. Let's see if you'll what will happen if you put 225 over here. So it is passing even at 225. Okay. With 10 mm dia bars. 225 and 225. Okay, so you can see the distributions are passing at 225, and even the HT at the support and the HT at a span, everything is good at 225. So that is quite good. Okay, so we can just go with this one, and this is safe in deflection also. So all the checks are getting verified from here. Now we will try one for two-way slab. Okay, so let's see what will happen with two-way slab. Let's go for 3.71, like S3, 3.71 and 3.86. 3.71, 3.86. Okay, so it is confirming that it is a two-way slab. Okay, now what is the self-weight? This is the calculated self-weight, so that is normally what we get. Okay, with the slab thickness of 100. So it will be reduced a little bit. However, it is not passing at this. If the floor finish load filling we will, even if we are reducing the fillings, live load here is 2. Even for that, it is not passing. Okay, so we will go with 113. Let's see. So it is going to good with 4.5 inches. Okay, that is good. Okay, but and now if we are at increasing the loads like this, partition loads, we don't have any kind of partitions, but filling loads, let's keep it 0.3. So even then it is going over there. Even if we increase the live load to 3, then even then it is passing. Okay, now let's see if whether it can pass for 9 inches or not. So it is passing for 9 inches also, but in the thickness section, if we are making it 4 inches, then it is failing. Okay, so we will have to keep it 113 minimum, that is 4.5 inches. Or if you want to go for the construction of 5 inches casting, then you can also go for that. But 113 is the minimum that we have to provide. Okay, so however, it is just showing in the software that it will pass. But if you are going for the manual calculations, it is not passing for this large slab. Other slabs are smaller than this, I think. 3.6 is 3.7, and yeah. So this is the largest one. So if it is the largest one is passing, then we can go with that. So what we have concluded, even if we are like providing the spacing of 9 inches for 10 mm diabar in all the directions, it will be passing clearly. So that is not an issue. Okay. Now, what we are going to do for the cantilever slab, that is quite good. We will just go with the same thing. But in practical, we will not go with this spacing. We can just go with the reduced spacing of in the bottom area. We will go for the shorter span, like parallel to the shorter span. We will place the slab at 6. Okay, like along shorter direction at top and along shorter direction at bottom, we will keep just 6 inches or 7 inches. Okay, even 6 inches is quite enough, like quite good, and that will not take up that much of the reinforcement. Or even if you are going for 7 inches, 7 into 25, how much it is? 175, like 175. Even then it is good. Okay, and along the longer direction, you can go with the 9 inches, or you can just make it 8 inches, that is 200. So this is more practical and no one will be questioning you. Okay, so but you will have to insist that this slab should be casted for 4.5 inches and not 4 inches. Even if the software is giving you some results, you can just go ahead and verify the manual method. So I hope everything is quite clear related to the slab design. If you still have any kind of question, you can simply connect me through the WhatsApp or call, or you can just comment below this video. And even if you've liked this video, just write in the video so that I can be motivated that you are getting benefited from this. And if you have any topic in mind, you can also write that in the comment section. If you have liked this video, hit the like button, share this video with your friends and colleagues. And if you want to join a professional training, then you can simply connect me on this number, which is 8433248864. You will also get this in description. Till then, take care. Bye bye. See you in the next video. Thank you, guys.